Alright, in section 5.3 we talk about solving exponential problems and logarithmic problems. The number one rule that you're going to use over and over and over again is definition of logs. So now they say solve this problem. Well, it's an exponential because it's got something raised to an exponent. You don't see any log in that problem. So get the exponential all by itself, equaling some number, and then rewrite it as a log. So log base 8 of 32768 equals the exponent 3x. You can write that using your change of base formula, and it actually comes out as just 5 equals 3x. Divide by 3 and you get 5/3 exactly. Number 3. So number 3, the original problem is, let's see. Number 3, the original problem is this one. Okay, so 0.13p equals p times 2 to the negative x. Well, you want 2 to the negative x all by itself. So divide both sides by p. Okay, and now you get a number to an exponent equals a number. Now you're ready to use definition of logs. Log base 2 of 0.13 equals negative x. So you use change of base formula there. And then you get this number, approximately. And divide by a negative 1 and you get positive 2.943. Number 5, you start out with this guy. Okay. And you want this to an exponent all by itself, so divide by 10,000. And so then you immediately have something to an exponent equals a number. You're ready to write it out as a log. So log base 1.05 of 2.5 equals the exponent 2x. Okay, we use the change of base to write it this way. Allows us to calculate the number. Then we divide by 2 and we get our answer. Very nice. Number 9. Okay, we want this guy all by itself without the 100 or that 100. So subtract 100 first. Brings that over and gives you a negative 22. Okay. Subtract 100. Okay, and then divide by a negative 100. And you get 0.22 equals e to the negative 0.01x. Okay, so now that's log base e of this number equals the exponent. Divide by negative 0.01, and that's your answer exactly. Actually, it's approximation. 11 says 55 equals this guy. Well, the problem you got here is that you've got the one you want to get all by itself is in the denominator. So the first thing you want to do is get rid of all those fractions by cross multiplying, right? 55 over 1 and multiply each side. And this is what you get. 60 equals this. Subtract 55. And then divide by 275. And now you've got it. E to a power equals a number. So now write it as a log. Log base e of that number equals the exponent. And so that's log of ln of this number, which is 0.4007333, and divide by negative 0.06 or 0.6 and you get 6.679. Number 13, what is that? What's the base there? It's 10. So 10 to the 5th equals x, or 100,000 equals x. What is this one? 4 to the 3 equals 9x. Well, that's 64 equals 9x plus 1. Subtract 1, divide by 3. This one you can write that as one log because subtraction becomes division. And now you're ready to write it as an exponential. E to the 10 equals x over 5. And then here I just multiply both sides by 5. So 5e to the 10 equals your x. Number 19, you want all your logs on one side and all the numbers on the other. So first thing I did was I brought all my numbers to the right by subtracting 7. And then I added 2 log x to get everything, all the logs on the left. And now I want to move that 2 into the exponent so that I can rewrite these as one log. They're being added so you multiply them. And now we're ready to write it with the definition of log. So 10 to the 18 equals this guy. Divide by 8 and then square root or cube root. And you get the cube root of 10 to the 18, which is 10 to the 6th, cube root of 8, which is 2. So 10 to the 6 over 2 equals x. 21, I wrote this together as one log. By addition becomes multiplication. And now this is something we haven't shown yet, but if you got a log of something, if you got a log of this equals the log of that, and they're both the same log, right, ln, then this has to equal that. You can actually take away the logs if they're both exactly set up the same way. Ln of this equals ln of that, so then this has to equal that. And then I throw everything to one side, factor, I get two answers, -4 and 3. Now when you plug in -4 up here in the original problem, you get ln of -4. You can't do that. You can't take the log of a negative number, so -4 is out. 3 is your only legitimate answer. Now 27 says purchasing power of an annual amount of certain dollars after 2 years at 5% inflation. It decays according to this formula here. And they tell you what P is and A is. So you plug all that in, and then you get this guy. Okay, now if you're going to solve that, you got to get this e to a power all by itself by dividing by 60,000, so you get 0.5 equals e to the x. Now you're ready to use the definition of logs. Log base e of 0.5 equals the exponent. And that's just ln of 0.5 equals this guy. Divide by -0.05, and you get your answer. Now part B says, what if your starting amount is P and it's 15 years? They want to know what A ends up becoming. So you get 50,000 equals A times e to the -0.05 times 15. And those two guys give you 0.75 negative. Okay, and if you figure out what that guy is, it's 0.47 something. Divide both sides by that, and now you know what A is exactly. 35. What does 35 say? It says they give you a demand function here, and at what price will the quality demanded equal 6 units? So Q is 6 for quantity, and you plug that in and you get -3. So 100e to the -3 is this guy. Rounded to 2 digits is that number there. Now B, they say, what will the price be when if the price is $1.83, how many units will be demanded? So they're asking for Q. So you put 1.83 equals 100e to the -q over 2. You want to get this e to this power all by itself, divide by 100. Now you're ready to use the definition of logs. Log base e of that number equals this guy. If you multiply both sides by -2, you get your answer. Is 8.002. Alright, in 37 it says supply function for a product is given by this equation here, where Q represents the number in hundreds of units. What's the price will be when the producers are willing to supply 300 units? So remember, Q is the number of hundreds of units. So if you're producing 300 units, Q is 3. Because how many hundreds? There's 3 hundreds. Okay, and Q is 3 there, so you got 100e to the 3 divided by 4. So 4 into 100 is 25. Crunch that down, you get 502. Number 40, they give you a cost function. Okay, and they say find the total cost of producing 100 units. So you plug in 100 in for X and you crunch it down and you get 5460.38. Then producing how many units will give a total cost of 7,500. So now you say 7,500 equals this, and you want to figure out what X is. Alright, so if you look at this guy in this shape, you want ln all by itself. So you got to get rid of the 1,700 and you got to get rid of the 800. So subtract 1,700 and then divide by 800, and now you're ready to use the definition of logs. E to the 7.25 equals x plus 10. Subtract 10 and you got your exact answer, and here's your approximate answer. 43, 43 says compound interest. What's the amount after 18 months? Remember, 18 months is 1.5 years. So 1.5 in there. Multiply it, you get this guy. Crunch it all out, and you get that amount rounded to 2 digits because it's money. And then part B says, how long before the investment doubles? Well, the investment was $8,500. And what's double that? Well, it's 17,000. So 17,000 equals this guy, and you got to figure out what t is. So divide by 8,500, and you get the exponent all by itself. Divide by 8,500, and you get the exponent all by itself. So now you say log base e of 2 equals the exponent. So that's just ln of 2 equals this guy. Divide by 0.115, and you get 6.03t, roughly 6 years. 45 is 5,000 invested at 9% per year compounded monthly. The future value is given by S equals this guy. What is the amount after 1 year? So t equals 1. And I think they tell you, they want time to be in months. So 1 year, t is actually 12. Kind of unusual. Typically, t is typically almost always in years, but they specifically want it in months. So 1 year is t is 12. Crunch it all down, you get that answer. Part B, how long before the investment doubles? Well, it was 5,000 before, so for it to double, it's got to be 10,000. So if you get 10,000 equals 5,000 in this guy, you divide by 5,000, and you get something to an exponent equals a number. And definition of logs again. Log base 1.0075 of 2 equals the exponent t. And you do change the base formula, and you get this guy, and this is how many months, or this is how many years. You divide it by 12, and you get 7.75, which is 7 years, 9 months. 3/4 of a year is 9 months. And now the last one, p equals this guy. You want to solve this for, 51, it says, I think they tell you what p is. Yeah, they say the price is 50, so you got to figure out what x is. So you want this guy all by itself. Subtract 10, divide by 5, so you get this guy. So it's log base e of 8 raised is equal to 3x plus 1. So you subtract 1, divide by 3, and now you've got an exact answer, and here's the approximate answer. Okay? So there you go.